Hello and welcome to Otten Math. In this edition of Otten Math, we're going to take on a couple problems involving solving systems of linear equations in three variables. All right, so let's take a look at the problems. So first, we're going to determine whether the given order triple 1, 0, 2 is a solution of the equation. So we're just trying to figure out and determine whether or not what we're given is in fact a point of intersection, or at least a point of intersection between the three lines that are described by the three equations. So the way that we're going to do that is we're going to substitute the values in for x, y, and z and determine if it makes the statement true. So let's take the first problem. So I'm going to substitute 1 in for x, 0 for y, and 2 for z. So I get 2 times 1 minus 0 plus 2 is equal to 4. And I can say 2 times 1 is 2, plus 2 is equal to 4. So the first equation checks out. 2 plus 2, 4, 4 is equal to 4. That's a true statement. Okay? Next equation, number 2, I have 4 times 1 plus 5 times 0 minus 2 is equal to 6. So 4 times 1 plus 5 times 0 minus 2 is equal to 6. So I get 4 plus 0 minus 2 is equal to 6. So I end up with 2 is equal to 6. That is not a true statement. So if one of the solutions or one of the equations does not hold true, then the order triple is not a solution of the equation, so I would say no. And we can just test the third equation just for fun to see if it works out. So third equation, 3 times 1 minus 0 minus 3 times 2 is equal to negative 3. I have 3 minus 6 is equal to negative 3. That checks out. But since this second equation doesn't check out, the order triple does not make the statement true, then unfortunately this order triple is not a solution of the equation. Okay, so now let's move on to a system of equations with three variables, and let's solve the system. So remember from our lesson, we're going to choose one variable that we're going to eliminate, and then we're going to choose two pairs of equations. So we have equation 1, equation 2, and equation 3. And I think just looking at this, I want to eliminate z as the variable, and then I'm going to use the pairs 1 and 2, and I'm going to use 2 and 3. So let's start with 1 and 2. So I'm going to line them up. I have x minus, and I don't need to multiply them by any constant because I can eliminate these two z values, the z values, on their own. Is equal to negative 1. So that's from the first equation. Second equation, x plus 2y minus z is equal to 7. And I end up with 2x plus 0y plus 0z is equal to 6. And I end up getting x is equal to 3. Okay, so either way, it looks like x is going to have to be equal to 3. So let's solve for this next set of equations. I have x plus 2y minus z is equal to 7. And then x plus y plus z is equal to 2. I combine the two equations. I get 2x plus 3y is equal to 9. So 2x plus 3y is equal to 9. Now I've already really determined that x needs to be equal to 3 from this first set of equations. And I have my second equation developed from a system of these two equations, number 2 and 3. 2x plus 3y is equal to 9. So if I take x is equal to 3 and I substitute x with 3, I end up with 2 times 3 plus 3y is equal to 9. Or 6 plus 3y is equal to 9. Or 3 is equal to, if I subtract 6 from both sides, 3. So y ends up being 1. So now by going through the second and third step, I solve for the two variables x is equal to 3 and y is equal to 1. So if x is equal to 3 and y is equal to 1, I can solve for z. Right? I'm going to use the first equation here. If x is equal to 3 minus 2 and y is equal to 1 plus z is equal to negative 1, and I'm going to move upwards here. So 3 minus 2 plus z is equal to negative 1, or 3 minus 2 is 1. I'm going to subtract 1 from both sides. So 3 minus 2 is 1, so 1 plus z is equal to negative 1. I subtract 1 from both sides, and I get z is equal to negative 2. All right, so very easily, I think, I solved for the three variables. In this case, some systems are a little bit more difficult. My order triple is going to be 3, 1, and negative 2. So we're going to go back and we're going to test that out in the second and third. We just proved that it was true in the first equation. We're going to go back and test it in the second two, or number 2, equation number 2 and equation number 3 to see if that holds true. So 3, 1, negative 2, 3, 1, negative 2. So I'm going to substitute these values for x, y, and z back in the second equation, and I get 3 plus 2 times 1 minus 2 is equal to 7. So that's 3 plus 2 plus 2 is equal to 7. 3 plus 2 plus 2 is equal to 7 is true. So this holds true. The ordered triple is a solution of this particular equation number 2. Now let's substitute those values in for the equation number 3 and see if they hold true. I have 3 plus 1 minus 2 is equal to 2. 4 minus 2 is equal to 2, so 2 is equal to 2. This particular equation checks out and holds true. All right, so we've just gone through the process of solving a system of equations with three variables. Again, we took a pair, two pairs of equations, 1 and 2, 2 and 3. We eliminated one variable, and as it turns out, in the first pair of equations, first system, we ended up eliminating two variables, and we ended up solving for one variable in that way. We used that value of x to solve for y in the second system. We found out that y is equal to negative 1. Then we used x and y values in either one of these three equations, but we used equation number 1, and we solved for the remaining variable, which is z. Then once we had our ordered triple, we went back and we tested that ordered triple in each of the three equations to determine if it held true, and it did. So this particular ordered triple is a solution of this particular system. Okay, last problem, number 3. Solve the system using the elimination method. And we're going to provide our answer. I'm just giving this as a guide to the students because they enter their answers in these automated device systems, and they have to enter one answer. So I asked them to add the coordinates x, y, z together to provide me with that solution. But we're just going to come up with the ordered triple for this particular video. So what I want to do first is figure out which variable I want to eliminate. And looking at the three equations, it looks like the y variable is going to be the easiest one to eliminate. And I'm going to select equations 1 and 2, and then also 1 and 3. All right, so let's work on 1 and 2 first. And what I want to do is I'm going to multiply 1 times negative 2. So I end up getting 6x minus 2y minus 2z is equal to negative 28. And then I take the second equation straight up. I have negative x plus 2y minus 3z is equal to negative 9. Okay, I'm going to combine these two equations. I get negative 7x plus 0y minus 5z is equal to negative 37. Right, now I'm going to choose equations 1 and 3 and combine those two equations. Let's do that over here on the left. I have 3, and what I'm going to do is I'm not going to do anything because when I combine these two, y is eliminated, so I don't need to multiply any of the terms by any constant. I will just combine them straight away. So 3x plus y plus z is equal to 14. And then 5x minus y plus 5z is equal to 30. I'm going to combine the two equations. I get 8x plus 0y plus 6z is equal to 44. Okay, now I have 8x plus 6z is equal to 44. Now let's see, which equation do I want to, which variable do I want to eliminate in this case? Well, let's eliminate the z variable, and I'm going to do that by multiplying the second equation that I've just derived by 5. All right, so I multiply this equation by 5, and I get 40x plus 0y. Actually, I'm going to multiply the first equation by 6. So let's start over again. Let's start on a different line. I'm going to have to multiply the second equation by 5 and the first equation by 6. I'm going to eliminate z by making the z, the coefficient in front of z, equal to negative 30 from the first equation and 30 from the second equation. So let's take care of the second equation as we started that. So I'm going to multiply that by positive 5. So I have 40x plus 0y plus 30z is equal to 5 times 44 is 220. And then I'm going to multiply the second equation by 6. So I get negative 42x plus 0y minus 30z is equal to negative 180 plus 42 is negative 222. I combine these together and I get negative 2x is equal to negative 2, or x is equal to negative 1. Nope, I just made a mistake. So x is equal to 1. Negative, if I divide both sides by negative 2, let's try that again with a smaller eraser. So again, it's very easy to make careless errors, as I do all the time. If you go too fast, it's always important to double check your work, as I do when I go through these videos. Okay, so negative 2x is equal to negative 2. Divide both sides by negative 2, I get x is equal to 1. Now I want to solve. If x is equal to 1, I want to solve for z. So I'll use it in either equation. Let's just choose the second equation that we developed. So 8 times 1 plus 6z is equal to 44. Or 6z is equal to 44 minus 8, which is 36. Or z is equal to 6. So I have x equal to 1, z is equal to 6. I'm going to put those back into any of these equations, substitute 1 for x and 6 for z, into any one of these three equations and solve for the remaining variable of y. I'm going to choose the first equation. Let's do that in blue. So I have now 3 times 1 for x plus y plus 6 for z is equal to 14. 3 times 1 is 3, plus 6 is 9. I'm going to subtract 9 from both sides, and I get y is equal to 14 minus 9, y is equal to 5. So my order triple ends up being x1, y5, z6. And that is my solution for this system of equations in 3 variables.